A cylindrical job with a diameter of 200 mm and height of 100 mm is to be cast using Modulus method of riser design. Assume the bottom surface of the cylindrical riser does not contribute as the cooling surface. Very important, or else it will lead to a wrong answer. So very important point. If the diameter of the riser is equal to its height, the only thing mentioned about riser here is this part. Then the height of the riser in mm is, 4 options are given. Now let us try to understand this question with the help of a diagram. So it has been told in the question that we need to cast a cylindrical object. Let's say its diameter is represented by capital D and height is represented by capital H. And we need to design a riser for that. Let's say riser, and let's say its diameter is small d and height is represented by small h. Now let us write down the given data in the question. So for riser, the only thing given in the question is the diameter of the riser is equal to height. So D will be equal to H. Then for the cylindrical object which will be casting, its diameter, that is capital D, is given as 200 mm and its height, capital H, is given as 100 mm. It has been told in the question that modulus method of riser design will be used. So what is modulus method? Now modulus method says that modulus of riser must be equal to 1.2 times modulus of the casting. Let's say this is equation A. Now if it is satisfied, then we can be assured that the molten metal inside the riser will take more time to solidify than molten metal inside the casting. Because if it doesn't happen, then it may lead to number of defects. So now let us calculate modulus of riser. So modulus of riser is nothing but volume by total heat dissipation area of the riser. So it is cylindrical in shape. So pi by 4 d square into h by, if we talk of area, heat dissipation area, so here we have got curved surface area through which heat will come out and the top circular area. Because in the question it is mentioned that bottom surface there will be no heat dissipation. So only one surface area, one circular area, that is pi by 4 into d square plus curved surface area, that is pi d into h. Now we'll simplify it. So let us divide this by 4 and multiply it by 4 so that we can cancel out pi by 4 and pi by 4. And it is already given in the question that d is equal to h. So here d square and d into h can be cancelled. So ultimately we get as h by 5, or we can also write d by 5. Now we will try to use this one in equation A. So modulus of riser is equal to 1.2 times modulus of casting, implies d by 5, which is modulus of riser, which we have calculated, will be equal to 1.2 into modulus of casting is nothing but volume by area of the cylinder, or d by 5 will be equal to 1.2 into what will be the volume of the cylinder. So it will be pi by 4 into d square h by, if we talk of area, so 2 circular area, so 2 into pi by 4 into d square plus 1 curved surface area, so pi d into h. So if we put the values here, so this will be 1.2 into pi by 4 into 200, diameter is given 200, into 100 by 2 into pi by 4 into 200 square plus pi into 200 into 100. Now you simplify this one. So let us divide it by 4 and multiply it by 4. So we will cancel out pi by 4, and pi by 4. From here 1 200 will be cancelled with 1 200 and this 200. So what is the remaining part? Is 1.2 into 200 into 100 by this becomes 400 plus 400. So 1.2 into 200 into 100 by 800. So we can cancel these two. 2 ones are 2 fours, 8 4, 25 times. So d by 5 is equal to this much. So if you bring d equals to 5, you bring here multiply with 1.2 gives 6 into 25. So this becomes 150 mm. So what will be the dimension of the riser, which is d will be equal to h, which is given in the question, will be equal to 150 mm is the right answer. Thank you.